Have you ever just looked up at the night sky and wished it would burst into color? Well, sometimes it does. And today we're going to dive into one of nature's most absolutely stunning masterpieces, the aurora.
I mean, seriously, what makes the night sky dance like that? It's a question people have asked forever. You see these shimmering curtains of light just rippling across the sky, and they look alive. So what's really going on behind this incredible celestial ballet? Well, let's get into it.
Okay, so the official name is the Aurora Borealis, but you probably know it as the Northern Lights. And really, at its core, it's just a natural light display. But even though it's all about physics, let's be honest, it feels like pure magic, right? This is where we'll start our journey to figure out how this whole thing works.
All right, let's set the stage here. Don't think of this as just some kind of weird weather. No. This is like the planet's very own live-action light show. A huge, spectacular display happening way, way up in our atmosphere. So what's the secret ingredient for this amazing show? It's the sun. Yep, our sun. It's constantly blasting out this stream of super energetic particles. And when those particles travel all the way to Earth and smash into our atmosphere, that's what creates this absolutely breathtaking glow. And get this, it all starts 93 million miles away. Incredible.
Now, if you want to see this show in person, and who wouldn't, you've got to head north, way north. We're talking places like Norway, Iceland, Finland, Canada, Alaska. Those are your front row seats. These high-latitude spots are exactly where all that atmospheric magic is most likely to go down.
Okay, so we've got the basics down. The sun is the source, and the poles are the stage. Simple enough. But how exactly do those particles make that long trip and create such an insane spectacle? It's time to get into the science behind the dance.
This really lays it all out, step by step. First, the sun shoots out these charged particles. We call that the solar wind. Then, those particles travel through space and run smack into Earth's magnetic field. Now, think of this field like a giant invisible force field that guides or funnels those particles down towards the poles. That's where they collide with gases in our atmosphere. The gases get all excited, and to calm down, they release that energy as light. And boom, just like that, you've got an aurora.
And here's a super important detail that a lot of people get wrong. The aurora doesn't care about the geographic north and south poles, the top and bottom of a globe. No, it follows the Earth's magnetic field. That's why the auroral oval, which is basically the ring where the lights show up, is centered on the magnetic poles. It's all about magnetism, not geography.
So, have you ever wondered why some auroras are just these faint little whispers in the sky, while others are just roaring, incredible spectacles? Well, it all comes down to what the sun's up to. When the sun gets really active, we're talking intense solar storms and powerful flares, it sends a way more powerful stream of particles our way. And that basically supercharges the whole display. The lights get brighter, more intense, and you can even see them much further south than you normally would.
All right, let's talk about one of the most mesmerizing parts. The colors. I mean, why green? Or red? Or even purple? It's not random at all. It's actually a beautiful bit of cosmic chemistry playing out right there in the sky.
Okay, this chart is basically the recipe for auroral colors. It's pretty cool. When those solar particles hit oxygen at an altitude of about 100 kilometers, that's roughly 60 miles up, we get that classic vibrant green that you see in most pictures. But if they hit oxygen much higher, say above 200 kilometers or 120 miles, you get a really rare deep red color. And nitrogen? Well, when the particles collide with nitrogen, that's what gives us those beautiful blues and purples. It's all about what gets hit and how high up.
And what about the motion? I mean, these lights aren't just kind of drifting along. Oh no! The curtains and ribbons of light you see are actually moving at incredible speeds. We're talking thousands of kilometers per hour. That's thousands of miles per hour. To give you some perspective, that's way faster than a speeding bullet. It's just a stunning visual of the sheer amount of energy being unleashed up there.
You know, we almost always call them the Northern Lights, but the Arctic doesn't actually have a monopoly on the show. This story has a twin. And the stage for this kind of thing goes way, way beyond just our little planet.
So, let me introduce you to the Aurora Australis, also known as the Southern Lights. It makes perfect sense, right? Since Earth's magnetic field funnels particles to both poles, the exact same incredible light show happens down in the southern hemisphere. It's like a perfect mirror image of the North, just seen by way fewer people.
And get this, it's not just an Earth thing. Auroras can happen on any planet that has two key ingredients, a magnetic field and an atmosphere.
Astronomers have captured these absolutely stunning images of auroras on the gas giants like Jupiter and Saturn, and they've even spotted faint ones on Mars. It's a truly universal phenomenon.
So before we figured out all the science, can you imagine what it was like to look up and see that? What did our ancestors think was happening? Well, they filled that gap in knowledge with some incredible stories, tales of gods, spirits, and huge cosmic battles.
Yeah, for ancient cultures, these lights were packed with meaning. Some believed they were the spirits of their ancestors, literally dancing in the sky. Others saw them as powerful omens, or maybe the flickering fires from a battle between the gods. They were just trying to make sense of something that was, both terrifying and incredibly beautiful at the same time.
And that really leaves us with a final thought to chew on. Today, we've replaced the myths with physics, but that sense of pure wonder, that's still there. It kind of makes you wonder, doesn't it? What amazing things are happening right in front of our eyes today that we just don't have the science to explain yet? It's something to think about.